Last year, Nvidia released DLSS 3.0 that included a feature known as frame generation, which boasted the ability to double your frame rates, and it largely delivered on its promise with a few substantial caveats, of which we'll get into in this video. DLSS 3.0 is now available for Unreal Engine 5.2, but should you turn it on? Can you even benefit from it? What's it even do? Let's jump right in. Now, full disclosure, Nvidia did send me an RTX 4080 for testing frame generation because a 40 series GPU was needed for reasons we'll get into soon. No money changed hands, and Nvidia has no input on this video's production. Okay, so I need to keep you all in the loop because DLSS 3.0 has a super confusing naming convention. Think of DLSS 3.0 as an umbrella, a kind of container for a variety of features and plugins all working together. It includes the DLSS super resolution stuff, but also frame generation, reflex, NIS, and streamline. I kind of wish they made that clearer, but it is what it is. Now you know. So in this video, when I say DLSS 3.0, I am referring to the global container features. And when I say DLSS, I'm referring to the AI upscaling tech. The two important features I'll be talking about, though, are DLSS and frame generation, or FrameGen for short. So let's take a look at how it runs and how easy it is to use. I'm going to make sure I'm running my level in play and editor mode here, and you'll see I have this overlay, which is set up thanks to the level blueprint you can find in the DLSS 3.0 sample project you'll get when you download it. Okay, so here we are in the city level. You'll see we're running at about 30 or so frames per second. It's definitely playable, but if I go ahead and turn on frame generation right here, pay attention to what happens to my frame rate. Now we're well over 60 FPS and everything is substantially smoother at virtually no real cost in terms of graphical quality. Now there are a few odd things happening here, especially on thin objects right here. You'll notice, pay attention to what happens with the lamppost here. We get a little bit of ghosting, a bit of oddness, but I don't think I would immediately notice it unless I was really paying attention to it. Would I use this for pre-rendered footage? Probably not, as we tend to pixel peep those shots a whole lot more. But for interactive stuff, it looks pretty great. Just doubling our frame rate with the click of a button is pretty insane. So moving on to the Valley of the Ancients demo right here, and you'll see we're at about 20 or so frames per second, which is really not that great. But just like in the city level, we're going to enable DLSS FG, frame generation, and just pay attention to how much our frame rate is going to increase. I'm about at 40 FPS-ish, and we're at 80 or so FPS. We've actually doubled our frame rate once again. And so suddenly our frame rate becomes a whole lot more usable, which is pretty insane. We were at around 20, 25 FPS, and now we're just kind of well over 45, 50 FPS. Seriously, this is pretty dang crazy. Now, again, just like in the city demo, you'll notice that the motion blurred areas do get a little bit artifacty and a little bit weird, especially looking at this area right here. But again, when things are in motion, when you are playing the game and you're not pixel peeping, you don't really notice these things, which is great. And FrameGen will improve over time. To be clear, it is not perfect. There are artifacts, but whether or not it's good enough really depends on you. Those of you using Unreal have probably heard of TSR, or Temporal Super Resolution, which is Epic's own upscaler that runs by default in Unreal Engine 5. The key word here is upscaler or upsampler, call it what you want. It essentially runs Unreal at a lower native resolution, giving a performance boost, higher frame rates, and then TSR works its magic and artificially upreses everything while preserving detail. That is what allows UE5 to run Lumen and Nanite so efficiently, because at a native resolution, it puts a lot of strain on your GPU. Nvidia's DLSS does a lot of the same by rendering the frame at a lower base screen percentage and using machine learning to upres things back up to your desired resolution. Simply put, these are two different kinds of upscalers with different pros and cons. Now, frame generation, however, which is included in DLSS 3.0, is a different beast entirely. That does something totally different. It uses machine learning to analyze sequential frames and motion data using optical flow hardware and adds new frames in between the ones your GPU has already rendered. potentially doubling your frame rate without any upscaling. It's making an educated guess on what the next frame should look like based on the previous frame and motion vectors provided by the engine. The cool thing is that frame generation does not need DLSS running to work. If you want to stick with Unreal default TSR and use FrameGen, you can. Any upscaler combined with FrameGen means that Unreal theoretically only needs to render 1/8 of the total rendered pixels. So why should you care? Vastly superior performance. This could be the key to real-time path tracing a lot sooner than expected. If we can render a fully path traced frame at very low resolution, say 540p, at 12 to 15 FPS, use TSR or DLSS to upres it to 1080p, and then use FrameGen to double the frame rate up to 24 to 30 FPS, we've essentially got real-time path tracing, which could be an absolute game changer. We are not there yet, but with how powerful GPUs like the 4090 are becoming, it isn't science fiction anymore. That said, a 40 series GPU is needed for FrameGen, but DLSS works fine on older GPUs though. Now I know what you're thinking, Nvidia is screwing over those of us with older cards just so that they can sell more of the newer cards. It's not that. It's because FrameGen is dependent on the optical flow hardware found in these newer cards. It's not some conspiracy to sell newer GPUs. That hardware is present on the 30 and 20 series cards. It's just physically much slower. So even if it is technically possible to run FrameGen on a 30 or 20 series card with a software unlock, the gains will be negligible. In order for FrameGen to really do its thing, it needs a certain frame rate to be usable, something roughly above 30 FPS to begin with. Otherwise, the generated frames need to do a lot of guesswork, which is kind of a bummer because low FPS is when you would need FrameGen the most. So DLSS 3.0 still needs a bit of optimizing for it to be viable on older GPUs. Now, you're probably wondering, how can we use this? How is FrameGen actually used on a day-to-day basis? FrameGen runs in Unreal in play and editor mode in its own window or running as a packaged executable. Unfortunately, it doesn't work in the Unreal viewport, so if you were hoping for a viewport upgrade, this is not it. I've tried getting frame generation to work with the movie render queue for offline rendering, but it did not seem to have any effect, unfortunately. This means that FrameGen is mostly for interactive content like games, ArchViz, etc. For those of you in virtual production, I did test DLSS 3.0 in NDisplay. DLSS works, but FrameGen seems to have flickering issues, which tells me it is generating frames, but they all come out black. It could have to do with the fact that I'm using a pre-release build of DLSS 3.0, or NDisplay is just not supported at the moment, or I'm just an idiot and I set it up wrong. It's very likely. But if any of you manage to get it up and working with the movie render queue or NDisplay, let me know in the comments below. I will stand corrected, and I'll update the information in the pinned comment. Nvidia, if you're listening, if you manage to get FrameGen working in NDisplay, VR, and movie render queue, you have a huge user base on your hands, an honest-to-God game changer. The DLSS quality settings here are really just about the initial screen percentage that DLSS starts with. The lower the base resolution, the harder DLSS needs to work. It has less data to work with in order to fill in the blanks. The more upscaling it needs to do, generally the lower the quality, but performance is a lot better. For those wondering, DLAA is using deep learning to enhance the image somewhat, but it is not upscaling anything like DLSS is. It's just giving you a high-quality, machine learning-based anti-aliasing. Hence the name, Deep Learning Anti-Aliasing. You can use DLSS for offline rendering in the movie render queue as well by adding the DLSS tab right here and choosing the desired quality settings. DLAA is rendering at full native resolution, so 100% screen percentage. Quality is 66.67%, balance is 58%, performance is 50%, and ultra performance is 33.33%. I did render some frames using the movie render queue for pixel peeping, and here are my results. Here we have the shot with DLAA versus Unreal TSR. This render comparison was pretty interesting to me because while the results look very different, I can't really tell which one is better. I'm leaning towards the DLAA render looking better simply due to the way it rendered the water, and also because the trees pop a bit more while preserving the shapes of the castle up here. TSR, however, is quite a bit sharper. But you can configure the sharpness of any DLAA or DLSS render with the following console variable. This is not some post-processing sharpening, it's actually sharpening the result itself at render time. When it comes to rendering the best possible top quality renders, the best way to do that is still by turning off AA entirely and using 16 plus temporal samples in the movie render queue. You can find the settings I use in my rendering guide available for free here on Gumroad, link below the like button. You can download DLSS 3.0 for Unreal Engine 5.2 here at the link below, and included are installation instructions in the PDF. Really, it's just about copying over these folders to your engine directory and enabling these plugins in your Unreal project of choice right here. There is even a sample project you can run to test out before adding DLSS 3.0 to your own project. In the project settings under the Nvidia tabs here, be sure the relevant checkboxes are ticked and you'll be ready to go. One major issue I have with this is that it's really hard to know if DLSS or FrameGen is actually on and working because there's no visual indication that it is running, nor can I know which quality setting is being used in the viewport. When I run my level in plain editor mode here, if I didn't have the Nvidia UI, which I have set up thanks to the example DLSS project provided by Nvidia, I would have no way to know what is happening. For normal viewport use, there used to be a menu window pop-up back in Unreal Engine 4.27, which doesn't exist anymore. My understanding, and I could be wrong, is that Epic is preventing developers from adding their own custom buttons to Unreal's UI shelf to keep it cleaner. Because in their defense, if you end up with a ton of plugins, I can see that it could end up very cluttered. But then again, A, it should be user choice. B, it would be really nice to have some kind of visual indication of which upscaler and AA method is being used. A debug watermark, something. Otherwise, you just have to trust it, and that is not okay. I don't think I'm the only artist out there who wants this. So for now, the only way to tell is by using the stat GPU console variable to see if temporal super resolution or DLSS is being used. And you still have to dig around the list here. And then you need to manually define the screen percentage right here using the values I mentioned before. It is a little tedious. So what are the main takeaways here? For frame generation, the pros are, free frames. 1.5 to 2x the frame rate at virtually zero cost. The motion blur and interpolation can look a bit weird sometimes, but overall, unless you're pixel peeping, it looks pretty good. But it only works if you're running plain editor mode in an external window or a packaged game, not in viewport. FrameGen doesn't work for VR, end display, or movie render queue for now. That might change. I hope it does. FrameGen also needs a 40 series GPU to run, but DLSS does not. As for DLSS, it's pretty awesome, especially if you need your renders to be done faster while preserving quality. This does work in a viewport as opposed to FrameGen. So I hope that helped. Thanks for watching, everyone, and as always, happy rendering.